2024 A-Level Combined Mathematics Paper 2 Part B, question number 17, Part A. Part B of this same question will be discussed in a future video, link in the top right. Part A of this question has to do with conditional probability. The question says, a box B1 contains 2 white balls and 3 black balls which are identical in all aspects except for their colors. It then says, 3 balls in total are transferred at random from box B1 into an empty box B2, and then it says a ball is drawn at random from the box B2. Now given this, the question asks us to first find the probability that the ball drawn from the box B2 is white in color, and second it asks us to find the probability that 2 white balls and 1 black ball were transferred from box B1 into box B2, given that we know that the final ball drawn from box B2 is white in color. Now for the first part of the question, what we need to do is to consider the 5 balls that are in box B1, which are 3 black balls like so, and 2 white balls, and considering that, consider the possible combinations of 3 balls that could have been transferred from box B1 into box B2. So considering that if we take 3 balls, we could have taken all 3 black balls like so and transferred them into box B2. Another possibility is that we took 2 black balls and 1 white ball and transferred that into box B2. Another possibility is that we took 1 black ball only and 2 white balls and transferred that into box B2. Now it should be noted, we cannot transfer 3 white balls into box B2 since we don't have 3 white balls. So therefore, we have 3 events, either transferring 3 black balls, 2 black balls and 1 white ball, or 1 black ball and 2 white balls. Now to denote these events, I'm going to write something like, let event E sub I denote the event of transferring, and I'll say transferring I number of black balls, and thus if we transfer I number of black balls, we must transfer 3 minus I number of white balls from box B1 to box B2. Now if we consider that, then the 3 events that we had become event E1, event E2 and event E3. Since you consider them, event E1 occurs when we transfer 1 number of black balls and 2 number of white balls, since 3 minus 1 is 2 number of black balls, into the other box. And furthermore, E2 comes when we transfer 2 black balls and 1 white ball into the second box, and E3 comes when we transfer 3 black balls and thus 0 white balls into the second box. Now considering that, what we need to do next is to find the probability of each of these events occurring individually. So first off, let's consider the probability of event E1 occurring. Now for E1 to occur, out of our 5 balls in which we have 3 black balls and 2 white balls, we need to transfer exactly 1 of our 3 black balls, and therefore we need to choose out of our 3 black balls just 1. And after that, out of our 2 white balls, we need to choose both of them. So we have 3 choose 1 times 2 choose 2 possibilities for choosing our 3 balls. Now after that, what we need to do next is to divide this by the total number of possibilities of choosing our balls to transfer. Now since we have 5 total balls and we need to choose 3 of them, the total possibilities are going to be equal to 5 choose 3, and therefore the probability of event E1 occurring is going to be equal to 3 choose 1 times 2 choose 2 divided by 5 choose 3. Now similarly, if we consider next event E2, for that event to occur, we need to choose exactly 2 of our black balls and we need to choose exactly 1 of our 2 white balls. So therefore, considering choosing the 3 black balls, we need to choose exactly 2 of them, and for the 2 white balls, we need to choose exactly 1 of them in order to get event E2, which is this event right here. So for that, we have to divide this number by the total possibilities, which is 5 choose 3. Now finally, for event E3, if we consider probability of E3, that's going to be the probability of choosing 3 black balls. So out of the 3 total black balls, you have to choose all 3 of them, and then out of the 2 white balls, we need to choose 0 of them. And then I divide this by the total possibilities, which is 5 choose 3. Now simplifying each of these down, 3 choose 1 is simply equal to 3. So we have 3 times 2 choose 2, which is simply equal to 1, divided by 5 choose 3. Now 5 choose 3 is equal to 5 factorial, divided by 3 factorial times 2 factorial. 5 factorial is equal to 120, 3 factorial is equal to 6, and 2 factorial is equal to 2. So we have 12 here, and 12 divided by 120 or 120 divided by 12 is equal to 10. Therefore, 5 choose 3 is equal to 10. So from that, the denominator here is going to be equal to 10, and we can substitute that, and we can see the probability of event E1 occurring is 3 over 10. Now similarly, if we consider event E2, for event E2 on top, we have 3 choose 2, which is 3, times 2 choose 1, which is 2, divided by 5 choose 3, which we just found is equal to 10, so we can substitute 10. Now dividing this, we can see we could divide these two and get 5 here and get 3 over 5, but for my purposes, I'm going to leave it as being 6 over 10. Now finally, if we consider last event, event E3, for this event, we have 3 choose 3, which is equal to 1, times 2 choose 0, which is equal to 1, divided by 5 choose 3, which is equal to 10, which is going to be equal to 1 over 10. And therefore, probability of event E1 is 3 over 10, probability of event E2 is 6 over 10, and probability of E3 is equal to 1 over 10. Now given these three, what we need to do next is consider the probability of getting a white ball drawn out of box B3 or B2, given that each of these events occur individually. So first, let's consider that event E1 occurred. If event E1 occurred, that means we drew two white balls and one black ball out of the box B1 into box B2. So according to that, if we consider probability of drawing a white ball and drawing a black ball out of box B2, then we can see if we have only one black ball, the probability of us drawing that black ball is 1 over 3. And therefore, the probability of drawing a white ball is 2 over 3. Now similarly, if we consider next event E2, for E2, we have two black balls and one white ball drawn. And therefore, after taking those balls into box B2, the probability of us drawing a white ball is going to be 1 over 3, and the probability of drawing a black ball is 2 over 3, since we have two black balls and one white ball. Now finally, if we consider event E3, in event E3, since we drew only black balls and 0 white balls, the probability of getting a white ball is going to be 0 over 3 or 0, and the probability of drawing a black ball is going to be 3 over 3 or 1 or 100% chance, because if we only have black balls, the probability of drawing a black ball is 100%. Now what this is actually representing is the probability of us getting white given that each of these events occurred. So the first event here is event E1, and therefore the probability here is the probability of getting white given that event E1 already occurred. So this is equal to 2 over 3. Now similarly, the second event here is actually showing us the probability of getting white given that event E2 already occurred, which is equal to 1 over 3. And finally, the probability of getting white given that event E3 already occurred like this is equal to 0 over 3, which I'm going to just write as being equal to 0. Now, given this information, what we can do next is to apply the partition theorem. The partition theorem states if we have any event that we want to find the probability of, which is in this case we want to find the probability of W, the probability of this event occurring is equal to the sum of all the probabilities of this event occurring given a partition, which in this case the first partition is E1, times the probability of that partition occurring. So probability of E1 plus the next probability of the event occurring given the next partition, which is E2, times the probability of that partition, which is probability of E2, plus the probability of that event occurring given the next partition, which is E3, times the probability of that partition for all of the partitions in our total set. In this case, we have only 3 partitions, which are E1, E2, and E3, and therefore from that, we can get the probability of W as being equal to the sum of all of these terms. Now, if we substitute in the values here, probability of W given E1 is equal to 2 over 3, probability of W given E2 is equal to 1 over 3, and probability of W given E3 is equal to 0, and if we go up, probability of E1 is equal to 3 over 10, probability of E2 is equal to 6 over 10, and probability of E3 is equal to 1 over 10. So substituting, probability of W given E1 is equal to 2 over 3, and we multiply that by probability of E1, which is 3 over 10. So we have 3 over 10. And then we have to multiply that, or rather add that again to the next value, which is going to be probability of W given E2, which is 1 over 3, times probability of E2, which is 6 over 10. and then you have to add that to the next probability, which is probability of W given E3, which is 0, times probability of E3, which is 1 over 10. Now adding these together, we can see this and this cancel, this 3 here and this 3 cancel, and this 3 and this 6 cancel to give us 2 here. We have 2 over 10, and another 2 over 10, and this part here is just 0. So therefore, if we simplify, we can see we get 2 over 10 or 1 over 5 plus 1 over 5 plus 0, which is equal to 2 over 5. And therefore, the probability of us giving a white at the end of our last row is equal to 2 over 5. So we can finally say, therefore, probability of the ball drawn from B2 being white is equal to 2 over 5. And with that, we are done with the first part of the question. Now moving on to the last part of the question. The last part of the question is actually quite easy, since all we have to do is apply Bayes' theorem. The question says, find the probability that 2 white balls and 1 black ball are transferred from box B1 into box B2, given that the final ball drawn from box B2 is white in color. Now if we consider the event of 2 white balls and 1 black ball being transferred from box B1 to B2, we will realize that this event is exactly the event E1 that we defined over here. So therefore, what the question is really asking us is to find the probability of event E1 occurring given that the final ball drawn is white in color. And therefore, what we're asking is to find the probability of E1 given W. So for this, what we're going to do is to go down and apply Bayes' theorem for probability of E1 given W in terms of probability of W given E1, probability of W, and probability of E1. So going down, for part 2, I'm going to write, for part 2, probability required is probability of E1 given W, and for this what we're going to do is to apply Bayes' theorem. So we'll say applying Bayes' theorem. Now applying Bayes' theorem, what we can see, theorem is that the probability of E1 given W is equal to the probability of W given E1 times the probability of E1 divided by the probability of W. And right now, we know all of these values. So going up, the first probability, which is the probability of W given E1, was equal to 2 over 3. So substituting that in, we have 2 over 3 times the probability of E1, which was equal to 3 over 10. So divide by, or rather times 3 over 10. And then divide by the probability of W, which was finally equal to 2 over 5. So divide by 2 over 5. Now simplifying this down, we can see on top we have this term and this term cancelling, leaving us with 2 over 10, and on the bottom we have 2 over 5, and therefore what we have here is this 2 and this 2 cancelling, leaving us with 5 on top and 10 on bottom. And therefore if we simplify this down, we can see we are going to get 5 over 10, which is equal to 1 over 2. Now therefore, the probability of event E1 having occurred, given that W already occurred, or the probability of 1 black ball and 2 white balls being transferred is equal to 1 over 2. And with that, we are done with this question. Now finally, let's go up and discuss the marks awarded for this question. So at the start of the question, when you find the probabilities of event E1, E2 and E3 separately, for each of these, doing the correct choose function substitution gets you 5 marks. And after that, when you substitute and find the correct value finally, you get another 5 marks. So 10 marks in total for each of these events' individual probabilities. Now after that, when you then consider the conditional probabilities like so for each of these events and write down each of their conditional probabilities separately, for getting all 3 of them correct and getting 2 over 3 for the first one, 1 over 3 for the second one, and 0 for the last one, you get a total of 10 marks. Now after that, when you then use the fact that each of these partitions added together is going to be equal to total probability of W and write this equation and substitute correctly, for the equation and substitution, you get 10 marks. And after that, when you simplify and get the final correct answer of 2 over 5, you get another 5 marks. Now for the second part of the question, when you write down the correct application of Bayes' theorem and substitute correctly, For this bit and this bit, you get a total of 10 marks. And after that, when you simplify and get the final correct answer of 1 over 2, you get a final 5 marks. And that is the end of this video. So if you have any feedback or questions, post them in the comments down below. Thank you for watching and goodbye.